So welcome to the video. Today we're going to take a look at how to do a one-way independent or between subjects or between participants ANOVA on version 31 of SPSS. So we're going to use this test when we have at least 3 levels within our independent categorical variable and when we have continuous data for our dependent variable. So for this example, we're gonna take data from this study I have open here. So this study looked at how well students were able to evaluate health claims in 3 different types of schools. So these data actually come from this website. So I'll provide this link in the description below the video in case you're interested in grabbing those data for yourself. Here's what the original data set looks like, but I've just taken a few columns, or just 2 columns actually, from this data set to create a simplified version. So what we have here is a school column, and we have 1, 2, and 3 in this column, where a 1 represents a general school, so just like a normal school. A 2 represents a health school, so these are schools that focus on things like nursing. And a 3 represents a vocational school, so these are schools that cover things like construction. And in this other column we have knowledge, which here is short for how well the students are able to evaluate health claims. So we're going to put these data into SPSS by going down to variable view at the bottom here, and then we'll give a name to our independent variable. So let's call this something like school type. So we'll use an underscore between those 2 words because we can't use a space. And then in the cell below that, in the name column still, let's give a name to our dependent variable. Just to keep it simple, let's call it knowledge, even though what we're really looking at is the student's ability to evaluate health claims. So once this looks like this, we can go over to this values column, and if we click on the school type row, we can get this box here to show, and then we can click on that, and then we can tell SPSS what those different numbers we saw represent. So 1 is a general school, so we'll go to this plus button, we'll press 1, and then we'll use this label bit to say that 1 equals general. We'll click the plus button again, we'll say that 2 equals health, and we'll click the plus button a 3rd time and we'll say that 3 equals vocational. And once we have this window looking like this, we can go to OK to close that. We can tell SPSS that we have a nominal or categorical independent variable and that we have a scale dependent variable. So once this looks like this, we can go down to data view and we can see that we have these 2 variables now mentioned at the top of these 2 columns, and then we're ready to paste the data in. So we can go back to this Excel file and we'll just click on the top left bit of data, we'll scroll down to the bottom, so we have a few hundred participants in the study. Then whilst holding shift, we'll click the bottom right bit of data to select all of the data, then we'll go to Command or Control C to copy those data, then we'll go back to SPSS, we'll go to the top left cell, we'll go Command or Control V to paste those data in. Sometimes it doesn't work, in which case you can go to edit and then paste, and then that should work. And we can see that we have the names that we allocated to the numbers showing in this column rather than the numbers themselves. And that's because in this view menu we have value label selected. If you unselect that, you just see the numbers. So I'm just going to keep that selected. So the first thing we need to do is check whether the data are normally distributed in each of the conditions or each of the schools in this case, because that is one of the assumptions of the one-way independent ANOVA. So to do this, we can go up to Analyze and then down to Descriptive Statistics, then across to Explore. We can then transfer our independent variable to the factor list and our dependent variable to the dependent list. We can go to Plots. We can untick stem and leaf, we can tick histogram, and we can tick normality plots with tests. Then we can go to continue and then to OK. And then if we scroll down to this tests of normality table, we can see that we have 2 options. So we have 2 different normality tests. So we have this Kolmogorov Smirnov test and we have the Shapiro-Wilk test. And as a rule of thumb, we usually use this test on the left when we have more than 50 people, in this case, within our conditions. So we can see that in each of these conditions we have more than 50 people. We would usually use this test in that case. If you had fewer than 50 participants in each condition, you would usually use the Shapiro-Wilk test instead. So I'm going to focus on this side of the table, and the most interesting thing is the STIG value. So we can see that for the general school, we have a sig value of less than 0.001, so this is also known as a p-value, and as this is less than 0.05, it indicates that we do not have normally distributed data for the data from the general school, and we have the same thing for health. We have the same p-value, or we have a value below 0.001, and here we again have a value below 0.05. So in all cases we have values below 0.05, indicating that the data in all of these groups are not normally distributed. And if we go down to the histograms don't look too bad, but you'd want this to look like a bell, so that doesn't really look like a bell. This one kind of does, but it's a bit sort of skewed to the left. There's a bit more data on the left than there is on the right, and the same thing here, it's a bit more to the left than on the right. So these histograms don't really have that classic bell shape that we're looking for, and that's consistent with these significant values here. So normally I would suggest that you switch to a Kruskal-Wallis test in this case, instead of doing the one-way between participants ANOVA, because the Kruskal-Wallis test doesn't make this assumption about normality. But since this is just a tutorial, we're just going to ignore the fact that that assumption hasn't been met, and we'll get on with running the analysis. So to do this, we can go up to Analyze, and then down to General Linear Model, then across to Univariate, and then we can transfer our independent variable to the fixed factors box and our dependent variable to the dependent variable box. Next we can go to post hoc, and we can transfer our independent variable to this post hoc tests for box. And there's a few options, but I'm going to choose the Bonferroni one just because it's a commonly used post hoc test. And so we're going to use this because we have 3 levels within our independent variable, and the ANOVA is going to tell us if there's a significant effect of our independent variable on the dependent variable, but it's not going to provide us with more specific insights than that. So we need to use a post hoc test to find out whether there's a difference between the general school and the health school, between the general school and the vocational school, and between the health school and the vocational school. So that's what this Bonferroni test is going to do. So once this looks like this, we can go to continue. We can also go to options and say that we want to have descriptive statistics, estimates of effect size, and homogeneity tests. So once we've ticked those, let's go to continue and then to OK. So that's going to run the test for us. I'll just quickly show you how to create a graph before we get into those results. So to do this, we can go up to graphs, and then we can go down to bar. This is fine as it is. We just need a simple bar chart. So we can go to define, and then we can transfer our independent variable to the category axis box. We can tick other statistic, and then we can transfer our dependent variable to the variable box. And if we choose options here, we can specify that we would like to have error bars for our graph. So once we've selected that, we can go to continue and then to OK, and that's going to generate this graph for us. If we want to edit it, we can just double click on it, and if we double click on the bars, we can make those thinner by using this bar options tab, and we can also change the color of those bars. If we go to this fill and border tab, we can choose a different color. And if we click any text, we can change the size using this menu and the style, and we can edit anything by clicking on it and then clicking on it again. For example, we might want to remove these underscores, and then we can just go to this red button and we can see that those changes are saved automatically. So let's now take a look at how to interpret the results of this test. Well, actually first we're going to take a look at this Levine's test of equality of error variances table. So besides normality, one of the assumptions of this test is that you have something called homogeneity of variance, which basically just means that the data are spread out to a similar extent in all of your levels of the independent variable. So what we want to see here, if we look at the based on mean row, is that we have a sig value or a p-value above 0.05. So in this case we have 0.272. This is above 0.05, indicating that this assumption of homogeneity of variance has been met. So let's now get on to interpreting the results of the ANOVA itself. So if we go down to this test of between subjects effects table, we can see that our independent variable school type is here. And then if we go over to the sig column, we can see that this value is less than 0.001. So as this is less than 0.05, it indicates that there's a significant effect of our independent variable on our dependent variable. Now let's take a look at this multiple comparisons table. And this is where we have the results of the Bonferroni post hoc tests. So here we can see we have general, and here we have health, and we have a sig value of 1. So this is way above 0.05. So we don't have a significant difference between the general and the health schools in terms of how well the students are able to evaluate health claims. However, between general and vocational, we have a sig value of less than 0.05. And between the health school and the vocational school again, we have another value below 0.05, indicating that there's a significant difference between those two types of school in terms of the student's ability to evaluate health claims. So that's essentially how we interpret the results. We also have some means and standard deviations here, but let's take a look at how to report the results, and we can take a look at these means a bit more closely then. So we have this example here, and I've said that a one-way independent analysis of variance was conducted to investigate the impact of school type, and then I've just listed the different levels of the independent variable in brackets there, and then I've referred to the dependent variable at the end of that sentence. And then I've referred to these normality tests. So the Kolmogorov Smirnov tests indicated that the data were not normally distributed in the general, health, or vocational groups. And then we've got these stats. So let's take a quick look at these. So here we're looking at the general schools, and we've got this W. Actually, this should be D. So I'm just going to change these W's to D's. The W is for the other normality test. So that's for the Shapiro-Wilk test. So for the Kolmogorov-Smirnov tests, we have a D statistic. So for general, we have 0.131 as the D statistic. And that's what we've reported here, just rounded to 2 decimal places. We have 101 in brackets. That's our degrees of freedom. And that's what we have here in this DF column. And we have this P or sig value of less than 0.001, and that's what we have here. And then we have the same thing here for the health group and the same thing here for the vocational group. So those are just the same statistics, but just coming from these health and vocational rows instead of the general row. And next we have Levine's test indicated that the assumption of homogeneity of variance was met. And then we have these statistics. So we have F equals 1.31, and that's coming from this Levine's test of equality of error variances table, and we have the Levine statistic of 1.31 if we round that to 2 decimal places. Then we have 2 and 286 as our degrees of freedom, and we have a p-value of 0.72, which is what we have in the sig column here. If you find that you have a p-value or a sig value here below 0.05, it would indicate a violation of the assumption of homogeneity of variance. However, this test is quite robust to this type of violation, so instead of just not doing the test, you could just modify your alpha. So what that means is when you're interpreting the results of the ANOVA, rather than using a alpha of 0.05, you could use a more stringent alpha of 0.01 to determine whether or not your results are significant. So that's how we report the Levine's test. Let's take a look now at how to report the results of the ANOVA itself. So I've said that there was a significant effect of school type on health knowledge, and then I've inserted these stats here. So we have F equals 9.99, and that is coming from this test of between subjects effects table, where we have this F value of 9.99 in the school type row. We also have these degrees of freedom of 2 and 286. Those are coming from the school type row and the DF column, and from the error row and the DF column. So we have a 2 and a 286 there. We also have the sig value of less than 0.001, and that's what we've reported next. P is less than 0.001, and we have this partial eta squared value of 0.07, so that's our effect size statistic, and that's just coming from this partial eta squared column and from this school type row, where we have 0.065, and we've just rounded that to 2 decimal places. So lastly, we have these Bonferroni post-hoc comparisons, and I've said that those revealed that those in general schools had significantly higher knowledge scores than those in vocational schools, and I've inserted some means and standard deviations. So here are the means and the standard deviations for the general schools. So those means and standard deviations are just coming from this descriptive statistics table where we have 11.54 and 3.41 for the general school, and that's what we have here. And then I've just done the same thing. Every time I've mentioned a school, I've inserted the means and standard deviations. So those are the ones for the vocational school, and those are the ones for the health school. And let's just take a look at these so we can see that the mean is highest for the health school, followed by the mean for the general school, and lastly by the mean for the vocational school. And in addition to reporting these means and standard deviations, I've reported p-values. So for example here I've said that the Bonferroni comparisons reveal that those in the general schools had significantly higher health knowledge scores than those in vocational schools, and I've said that p equals 0.002. So that p-value is coming from this multiple comparisons table, and we have this general row here, and we have this vocational row here, and we can see that we have this p-value of 0.002. And so essentially every time I've made a comparison between two types of schools, I've included a p-value from that table. So that's essentially it for the one-way independent ANOVA on version 31 of SPSS. I hope that was helpful. If you have any questions, let me know in the comments and I'll try to get back to you. Thank you very much for watching, and I'll see you next time.